Hello everyone, my name is Rohit Das. Welcome to my channel. And today we are going to see, learn, understand, and implement data preprocessing. You might have come across this term data preprocessing several times while you might have Google searching maybe data mining. But we are going to use this data preprocessing for our machine learning in Python. So this data preprocessing is like your step 0. It is what cleans your data and makes your data ready to be implemented, to be used in your machine learning model. And that is exactly what we are going to do. So for this, I am going to use this Jupyter notebook. You can use maybe Google's Collaboratory or something else according to your personal preference, but my personal preference stands with Jupyter notebook, so I'll use this. So to work on a data, we first need to import a data. We first need one, and here it is, data.csv. I'll upload this on my Jupyter notebook, and here's the data. And of course, well, it's a comma separated value and not a very good representation. So I'll move to Excel sheet, where you can see there are basically 4 columns of the data: gender, age, salary, and bought, whether a person has bought a certain product or not. So you could say that this bought basically depends on age, salary, and gender. Maybe it's a product which actually targets people on basis of the gender, age, and well, salary is always some factor or another, some factor while buying things. So the salary is also one part in this. So you could say the bot which depends on the other three, and while the other three, like gender, does not depend on either of the 3 columns, or age does not depend on the rest of the 3 columns, and similarly salary cannot depend on the rest of the 3 columns, and they can be said to be independent variables, while your bot is your dependent variable. Usually in machine learning, this dependent variable is what we predict using several independent variables like gender, age, salary, and many other. So for this, we need to prepare this small data set appropriately for a computer to understand and apply machine learning on it, whether it be regression, classification, clustering. Pre-processing is always a must. Before every start, you need to pre-process your data. So let's just go to new Python 3. I'll just name this data pre-processing. And when it comes to machine learning in Python or data pre-processing, you need a couple of libraries always, and one of those are NumPy. Import NumPy as np, then there's import pandas as pd. There's another module which you will use a lot in your future machine learning models once you are well versed with data preprocessing, and that is matplotlib. But you will be using this to actually visualize your data, maybe in a scatter graph or a bar graph. But over here, we are just going to make our data in cleaner and easier to process for our computer, so we won't be needing the matplotlib. So we'll be running this code cell, and now we will be importing our data set into our program. So for that we'll need the pandas read csv data.csv. And now, as I explained earlier, this last column is our dependent variable while the rest 3 are our independent variable. We need to handle them differently as well. So while we do import them, we have to handle them differently, like x equals to dataset locate for, we need all the rows but we do not need all the columns. X is only going to have independent variables, so we only need the first 3 columns, so which is column number 0, column number 1, and column number 2. Python always starts with 0, so that's why we are starting with column number 0. So we could add a range here. Similarly, we have added a range for row. We have only added a colon, which means all the rows. We'll add a range here, like starting from 0, and we need up till 3 because Python never includes the upper value. That is, if we give 0 to 3, it will give every value starting, every column starting from 0 before up to 3, up to before 3. So 0, 1, 2. But we could do this in a much better ways. We could just remove this 0 over here. It will take all the columns before 3, and since we are doing this on Python, we can actually have a -1 over here dot values. The -1 basically stands for Python's negative indexing. So this is the last column, so this is the -1th column, then -2, then age is the -3 column, and so on. Further, we have to import, we have to, you see the column with dependent variables. So again, we need all the rows, but now we do not need to add a range of columns we need to see. We just need one column, so we'll just mention that one column, and that one column is, as you have guessed it, it's -1, because over here we are taking all the columns before -1. So the one column left is -1, column number -1, or which is also column number 3 dot values. So now once I run this, we have x, and we have all the independent variables in x and dependent in y. So print x and print y, and you can see is all the independent variables over here, the gender, the age, the salary, and the dependent variable whether they have bought the product or not. So we have successfully brought the data into our Python program, and now we need to handle this. So as you can see in this data set, one problem which you can clearly identify is that there's a blank space over here. So we need to learn to handle this blank space. So we can do this using a very good machine learning tool in Python, which is the Scikit-Learn library. And from Scikit-Learn library, we are going to use the impute module. Sorry, not impute, impute. And from that, we are going to import a simple imputer class. So what the simple imputer class is going to do is help us handle this blank data, which is actually represented as NaN over here and blank as in our Excel sheet. So we'll handle this. So first we'll create a class of a simple imputer. Sorry, we'll create an object of the simple imputer. Imputer equals to, we'll call the class simple imputer. We'll need some parameters to pass. So one parameter is missing values. Now what type of missing value are we dealing with over here? It is the NaN. So it is np.nan over here. And how do we want this to be dealt with? What is our strategy to deal with this? And our strategy over here is going to be mean. We want to find the mean of all the salaries, and accordingly the mean, we want that to be over here. So for this, we have created an imputer object which will now handle all the missing values which are of np.nan type, and the strategy it will use is mean. So we need to fit a data into this imputer object, and for that we'll use .fit method. .fit, and in .fit method we'll take the data which we want to, in which we want the imputer to handle. So for that we want x, since that is our data with independent variables. But we do not want this imputer to handle the zeroth column, as it is not only a string but we do not need any way to deal with it. We only need to deal a mean strategy on numerical values. So we will put x all rows but only the first column up till the last one. You could also add 3 over here, like all the columns before the third column. And once your imputer object is now fitted and has handle all the nan values in this dataset appropriately, we need to transform this data. So how can we do this? We'll just put all the places where we need the transformation done, that is all the rows, but for a column we need only the first two columns. Now there is no blank value in the first column, but just remember there might be. This is a very small data set with only 10 data values. You might deal with some with 100 values or maybe more than that, and you don't know where you might find a blank value. So anywhere where there's a potential of having a blank value, you need to take that into consideration while using the simple imputer. So equals to imputer dot transform, we need to transform that. So what places we need to transform? We need the transformation to be done in all the rows, but only in the first and the second column. And whatever transformation will be done using imputer.transform, it will now be saved in x of all rows, but only the first and the second column. Now you'll see a small change over here in our independent variables. That is for where there's a female of age 34 and a blank value, you will now find female of age 34 with a certain salary, which is basically the mean of all the other salary values. So now we don't have any blank space over here, and your data set can be applied in your machine learning model. But furthermore, this we are not done, because now we also need to handle the string values. Since your computer cannot handle your string values, you need to handle them yourself for the computer and then feed the data set into your machine learning model. So to do this, we need encoding. To encode, again we will use the Scikit-Learn library, and from Scikit-Learn we will use the compose module, and we'll be using column transformer class, and from again the Scikit-Learn library and pre-processing module, we are going to import one hot encoder class. One hot encoder, this is the encoding style which we are going to use to encode our string value of male and female over here. So before I implement this any further, I would like to explain how this one hot encoder actually works. So your one hot encoder is basically something like, let's just say now we have male and female, only two different values. So let's just say it will make it as 0, 1 as a male value and 1, 0 as a female value. A female value. So this is basically like the first part stands for the female while the second part stands for male. The 0 means female, the 1, and over here again this value is for male, so 0 means switch off the female value and switch on the male value. Similarly over here it is switch on the female value and switch off the male value. So 0, 1 becomes males, 1, 0 becomes female. A better example would be like using three different methods, three different values. Let's take it another value in gender, which is rather not say. So we'll keep this 0. Some people might actually refuse to reveal their gender, and that's completely alright. So there's 0, 0, 1, and this value will represent rather not say. So as you can see over here, the first values represent female, the second values represent male, and the third values represent rather not say. So the first and the third value over here is switched off, which is female and rather not say, and the male value is switched on. Similarly over here, the female is switched on, and male and rather not say is switched off. And over here, the male and female both are switched off, and rather not say is the only value that is switched on. This is how your one hot encoder works. So now to implement this encoding method, encoding class, we'll need to create an object of the column transformer. So I'll keep the name as CT, and the column transformer, it will take two parameters, transformers, and the transformer actually take a list of tuples as its value. So in Python, the list is represented using square brackets and tuples using parentheses. So whatever transformation we are doing over here, it is an encoder. This list of tuple will take three values. One, whatever transformation we are doing, that is encoder. How we are doing it, which is one hot encoder. Since this one hot encoder is a class, we need a parenthesis. And last but not the least, another list, a small list, but this list will consist on which column do we need this encoding done. And as you can see here, gender is the 0th column, the value would be 0. And now the second parameter, once we move outside the list, the second parameter would be remainder. That is what to do with the remaining of the columns, and that we'll keep it as pass through, just pass through them, don't do anything, we don't want them to be changed. And we are going to use this column transformer in the entire data of independent variables. So x is equals to np.array ct.fit. Earlier we had used the fit and transform differently. Now we are going to fit and transform together on the same data. So on the x value we are fitting and transforming the data in the x value together. So once I run this, and now I'll just print x and run this, you see your gender value has changed, which was earlier male female. Now it is 0 0 and 0 0 1, like 0 1 1 0. So over here you can see the first value was, I think, male. So yes, the first value was male. So the female has been switched off, and the male, the second, is switched on. While in the female one, the first value 1, which stands for female, is switched on, and the second value, which stands for male, is switched off. Now I was showing one for the rather not say as well. You see the changes in this accordingly. So I'll just take one random female value and make it rather not say, and take another is the same male value and again make it rather, okay, again make it rather not say. So I save the changes, and now I'm going to again import the entire data set over here, again run the code cells, and we again need to have the imputer. And now once we reach the column transformer, you'll just see a difference. Earlier we had only two gender values, male and female. Now we also have rather not say. So you see the difference over here. So once I run this and x, you see now, and earlier where how there was only 0 1, now there's 0 1 0. So the first value, which was for male, represents female switched off, rather not say switched off, but male to be switched on. Similarly for the female, where the female is switched on, but male and rather not say are switched off. And then there was another value where over here female and male both are switched off, but the rather not say value is the only value that is now switched on. Okay. So this is how your one-hot encoding works. We still have all the 10 data sets, and we have made some changes in the gender part where two of them are now rather not safe. So we saw one method of encoding, now we'll see another encoding method, and for that we will again use the Scikit-Learn library, and from Scikit-Learn library we'll again take pre-processing module, and but this time we'll be importing the label encoder class. Now label encoder is like a relief if you found the one hot encoder class implementation a bit difficult, because in label encoder once you create the object of the label encoder where it is a LE equals to label encoder is a class, so parenthesis LE is the object of label encoder, and we do not need to insert any parameters for label encoder. Yes, that's it. Label encoder, you do not need any parameters. Over here directly, we need to apply label encoder on our in set of dependent variable. We're using label encoder over here on the y variable. So y equals to le dot fit transform will be fitting and transforming a certain data value into the le object together. Fit transform y. I'll be creating another code cell over here with a print y. Now once I run this and then this, you see that it has now transformed the string values into numerical values which the computer can easily understand. Now, unlike a one hot encoder where it was like switch on and switch off, label encoder is of a much simpler way. That is, it gives a direct value. Over here your 0 directly represents no and 1 directly represents yes. So you do not have like any switch on switch off feature. One number represents one value, that's it. This is direct method. That is exactly why you did not have to use any column transformer or anything like that, because over here if you look closely, this is no longer one single column. Where the gender earlier was one single column, it is now divided into three columns. That is female switched off, male switched on, rather not say switched off. The gender is now a collection of three different columns, and that is exactly why we need to use column transformer. We had to transform the entire column of our data set, while over here in label encoder the value of the data set was just changed. There was no transformation needed, which made the work simpler. Now for the last two parts of our machine learning data preprocessing is one feature scaling and the other one is splitting our data set into training and test set. And this is basically a very general question in machine learning, whether to apply feature scaling on the entire data set first and then split into training and test set, or split into training and test set first and then apply the feature scaling. Well, before I give you the answer to that, I'll be explaining what both of them are. So training and test split is very simple and easy to understand, in which you split your data set into two. One part for your training of your machine learning model and the other to test whether if it is efficient, whether it is working properly up to the mark how you want it. And while feature scaling basically scales down your values in your data set into a very strict ordered given set of range. So as you can see over here, the salaries, they are very high and they can actually like shoot high above. So what we can do over here, like so that all of them are have one prior, none of them have a priority over the other, none of these data is overshadowed by the other. We can apply feature scaling so that we can give all the values a given feature, given scale. It could be between 2 and -2, 1 or -1. So this is basically a general question whether to apply the feature scaling first or whether to split the data into training and test set. And the correct answer, and the only answer, is you actually, well, split the data into training and test set first. Why do you do this? Because once you split your data into training and test set, your training and test set are completely different data sets now. Your training and test set, they need to be featured, scaled according to the values each have independently. In other words, your feature scaling of the test set should not be done on the basis on the values of your training set. So first we split the data into training set and test set, and that again we can do it using the Scikit-Learn library. And from Scikit-Learn library we'll be needing model selection this time. For model selection we'll be importing a class called train test split, and to use it is completely easy. Just you need to give xtrain. Now this xtrain is basically your variable of your training set of independent values, then xtest your independent values in the test set, then there's ytrain, your training set values for your y for your independent values, and your y test, which you will use again to compare your given result, to compare the efficiency of your machine learning model. So you go to the training test split class, and over here in this class you give the x value, the entire x, the entire y. You also give the test size. Now usually test size is not usually, always it is smaller than your training set. You need as many as data to train your machine learning model, but you need only a certain amount of data to test it accordingly. So whenever you do training test split, it is best practice to have a smaller test size. That is over here 20%, which are represented by 0.2. You can actually find some test split as 0.4, but that is actually when you have a very huge data set. So even with 40% of your data gone from your training set, only 60% remaining, you can still get a large variety of data. Since we have only 10 data values over here, we'll only be having 20% of the test size. And the next parameter would be the random state. Now I do not want the first 8 values to be in my training set and the rest 2 in my test set. I want the values to be randomized. Any 2 values from the entire data set in my test set, and that is why I have set the random state equals to 1. And we will also print the x train. We will, along with x train, we will also print the y train. Then along with the y train we also have x test, and after x test we have y test. So to print this data we need to run this code cell first, and your data has successfully been split into training set and test set. So use your training set, and these two will get your test set. So if you look clearly, you see there are only now 8 values in your training set and the rest 2 are in your test set. So these are the data which you use to train your machine learning model. Your machine learning model is going to be trained according to this data and it will be tested according to this data. This is your result of your training model. So your training model is going to work according to your X train and Y train, while your test model is going to work on this value and going to predict a value, and we'll compare with a Y test. That is how your general machine learning model works. And now for the last part, we have the feature scaling. So again, the Scikit-Learn library, we saw throughout the entire tutorial how important and how useful this Scikit-Learn library actually is. And from Scikit-Learn library will import the pre-processing module, and we'll import the standard scaler for our feature scaling. Your feature scaling can actually be done by a standardization process or normalization process. I won't be going too much detail into this. I want this tutorial to be as simple to understand and not complex. So to keep it simple, I'm saying that this we have used is standardization process, the standard scaler, and we need to create an object for the standard scaler, and then we need our X train to be feature scaled according to the standardization of standard scaler. And so we'll put our X train fit transform with the SC object of the standard scaler, but we will take all the rows but not all the columns. Since our gender column is perfect as it is, and we have done a beautiful one-hot encoding over there, we do not need to make any changes over there. But rather, we could directly make changes over here. So for our age and gender. So we need only columns of age and gender. Since the column for age is 1 and salary is 2, we need all the columns starting from 1 to the n in the X train. But if you remember, I did say your gender is not represented using single column anymore. It is now representing using 3 columns. This 1.0, 0.0 and 0.0 all are 3 different columns, which represents 1.0 as female as on, 0.0 male as off, and rather not say 0.0 again as off. There are 3 different columns used to represent one single value. So your age now starts with 0, 1, 2 and 3 from the third column. So we'll take from the third column the value and apply sc dot fit transform, and we'll fit transform in all the rows but only on the third column and above. And similarly we'll do it for the X test as well. So yeah, there it is, sc dot fit transform. Again we are fitting and transforming the X test, X and X train from third column and forward simultaneously, and run. Wait a second, what was the problem over here? SC could not broadcast. Okay, so we do not actually add fit over here because your fitting is actually done in the X train as well. Alright, so there's another error over here, and that would be we have to add X train and X test over here, not X. We are not doing it according to the entire data set, but only according to the training and the test set. And you also do not need to add a fit for the training set because I've already fitted the standard scalar with the data of the training set as it is, so you do not need to do it again in the test set as well. So those two were our errors. Good thing they were solved pretty quickly. And now once we go to training set, and then we also see the test set, you find a big difference now, and there it is. So you can see now your values for your training and your test set are actually between -2 and 2. They have been featured scale between -2 and 2 so that they could be worked on in your machine learning model much more easier or a better way. So let's just review or recap what we have done in this tutorial so far. It's been a very long tutorial and maybe a bit tiring one. We had covered a lot of things in data preprocessing. We had covered almost everything you could say, but there are still many things you could do on your own. For example, as I said, there's a strategy of mean over here. You could apply median, and you could actually see many other different things. You can work on different data sets and try to split them. Maybe for a last data set, you might want to try a test size of 30% instead of 20%. And to recap everything, we have first imported a NumPy and pandas libraries. Then we have imported our data sets. Then we handle our missing value data using the simple imputer. And then we applied the one-hot encoder on our gender to encode our string value so that it could work on our machine learning model. And for our yes and no value, we used the label encoders. We split the dataset into training set and a test set, and then we also feature scale both our training set and our test set. Oh, well, that was pretty long. Hope you enjoyed it, hope you learned it, and thank you very much. Please do share and subscribe our video and put a like as well. Thank you.